Hey everyone, welcome to our live stream today. We're going to talk about working with tables in MATLAB. So this is great for tabular data, and we'll show some examples and share some documentation links and answer any questions you have. So this is live. Make sure you answer or ask any questions in the chat, and we'll try to get to all of these today. So I'm Heather Gorr, and I'm a product manager for MATLAB, and I work very closely with the teams who work with develop tables and some of the other data types. So I'm really happy to share some of this with you, and like I said, answer any questions that you have. All right, without further ado, let's go into MATLAB. So first, I wanted to just talk a little bit about what a table is and why you might want one. In order to do that, I'm just going to quickly read a table, and I'll talk more about doing all these things later. And these are all from the example in the documentation, so you should be able to follow along with this very easily. There's nothing really special that you need. So we'll talk, just before I jump in any further, I'll go ahead and talk about the agenda a bit. We'll talk about what a table is and what it can do for you, how it's different from other MATLAB arrays, and then how to create them, how to really work with them. We'll spend a lot of time on extracting data. We hear a lot of questions about how to get data out of them, sort of like row column indexing like you have with matrices, but tables are a bit different. So we'll go through a lot of those kind of questions. And then doing some fun stuff like applying functions, different kinds of operations, and then joining and concatenating tables together. So like I say, anything that anything that pops into your head as we're going through this, or things that you've been struggling with, if you're working with tables, feel free to ask those in the chat, and we'll try to get through as many questions as we can. So a table in MATLAB is similar to other arrays that you might see. It's actually really similar to a spreadsheet, right? So you have sort of labels on your columns. So this is the region or the location, outage time, loss. This is power outage information. Like I said, just from the documentation. I think it should be more clear. I think this was actually a CSV file. Yeah. So just it basically looks just like a spreadsheet, like I mentioned. The thing that's nice about tables is that you can have different data types in each column. And so that's different than what you typically would see with MATLAB, where you're working with a matrix or an array where everything needs to be consistent. So with a table, it just needs to be consistent in the columns. So each column needs to be the same data type the whole way down. And this is really handy because a lot of times this is real life. You have record or observation information like this, and it may not all be numeric data or might not all be strings. So the table and timetable, for that matter, are great data types for this kind of data. So just to talk a little bit more, actually, I'll open this up in the variable editor. So, you can see it is basically similar to a spreadsheet. If you're working in the variable editor, you can also change the column names if you prefer. And I wanted to mention here, actually, you should be able to see this in the command window. It actually shows you what I just did. So if you're just getting started, it's really great to start working with it in the variable editor or in the live scripts, because then you don't have to start by just remembering the code or going to the documentation to try to find all of the syntax. So a couple other things I just wanted to mention, like all MATLAB arrays or many MATLAB arrays, this needs to be rectangular in general. So each, we have the different columns with different data types, and we have the number of rows, but it's still sort of a rectangle in the end. And anything that doesn't have data that isn't sort of like that, you can put missing nan or nat in this case for a date time. So those are just a couple of pointers, just kind of in general. Another thing that you might notice here is that there's this data.properties.variable names. So what is that? Well, let's take a quick look. So tables actually have metadata attached to them. And this is really useful, especially if you have information about different data sets. You can put in your own descriptions, if you're sharing this with other people and you want to make some notes about when these measurements were taken. And this is also where you change the variable names. You can also have row names. So if you have, something that makes a lot of sense to, attach to the row, In this case, we have repeated information, but say that we had just, Southwest, Southeast, West, Midwest. We could actually change those as the row labels, which we'll talk about later, will be helpful for indexing or accessing what we want. And so just a few more notes here. There are a couple of things like variable units, variable descriptions, continuity. So these are just, these go along with each of the variables in your table. So just, again, more information that you can attach to them. And then to get them, to change them or to get the property information, you just add dot the property. So if I wanted to look at all of the variable names, I could do that very easily. Like that. If I wanted to change all of them, you can pass in, brand new variable names if you like. All right, so that takes care of some of the basics, I guess, of tables. I wanted to just quickly mention that there's also what's called a timetable. And in this case, it would make sense to use a timetable because there's a time associated with it. So if you were joined us in a previous live stream, I guess it was a few weeks back, we talked about synchronizing data by time, and we used timetables. Very similar to a table, it's just that, instead of a row label like I talked about, it has a time instead. So if we wanted to change this, we could say table to timetable. And then you see that it actually, will be much easier to see in the variable editor, but it actually uses the time as the label. So that way you can access them by time, and it doesn't necessarily keep it as a variable if you're trying to do calculations and things like that. So you notice that I used, where'd that go? Table to timetable. So there's a couple of different ways that you can convert tables. So if you already have a table, you can use table to timetable, or if you have a struct, you could do struct to table. There's a lot of different ways that you can convert these. And you also could create one from just different variables. So let's say, actually, I'll load this in. Our patient's data is sort of the classic example that you'll see in the doc. It has just a bunch of information. And so if we wanted to create a table from that, we could just pass in our variables like height, age, something like that, and we've got our table. So there's a couple of different ways. We saw, you could read to create one, you could create one from variables, and then there's array to table, cell to table, struct to table, those kinds of things. Just a couple of questions here. Do you have a download for the CSV? So this is in the documentation. I'm not sure where it came from, but it should be able. It's basically just in the MATLAB examples. So that's where the CSV is located if you want to take a look. And I can probably share a documentation link for any more information about the data. Actually, I will jump into the documentation now just to show you where some of this information comes from. I just searched. If you search tables in MATLAB, you can find it easily. And this is a great resource. We can put it in the chat. And it has pretty much everything that you need in one place. There's a couple of videos. There's a lot of different functions, things that we just talked about, like struct to table, those kinds of things. And then there's a bunch of examples. So the things that I'm showing are really just, they're all basically contained here somewhere. I'm just kind of picking and choosing little pieces of the examples. All right, so let's talk a little bit more about, there was one more. How do you view data types of all how do you view data types of all columns without using var type, for example, df, d types, and pandas? Good question. So there's a couple of ways. I'll actually wait a bit to show one of the ways, just so it makes sense with what I was talking about. But I'll show very quickly how to get the data types. If you do a summary of, what should I just do, data. So it shows you information, again, quickly, just kind of in a one-liner about each of the variables in your table. And you can capture the output of that too if you just put, T or S equals summary, X equals summary, something like that. You can retain all that information. All right, so That's one thing that's just helpful. Again, just if you, especially we're looking at example data that's maybe 100 rows. A lot of times, you have a lot more than 100 rows. I guess this is a bit more, but doing something like summary. There's also head and tail, sort of like a Linux thing. If you want to just quickly check the first 10, you could pass in just a few, again, just to kind of get a sense of what you're working with. So something I definitely want to do, some of these I want to convert. So I wanted to show you how to work with individual columns of a table. The thing that I think is really easy and kind of slick about tables is that you can just quickly use dot notation. So for example, data dot region, and I want to change this to categorical. So that's how I keep doing this. So you can use dot notation to just access one column at a time. And so you notice there were, when I hit the tab complete, it gave me the variables. So that's a great way to just get at the actual data itself. If we go back to our variable editor, actually, it's a good way to show it too. So let's say we wanted to just extract our outage time. If you right click on the variable editor, it'll give you a couple of options. So there's a new workspace variable from selection, and you could create either a new table or a separate variable or a cell array. So let's just show both of these. So there's creating a new table and then creating a new workspace variable. So it's basically just showing what I just showed. It's nice to not, if you don't want to worry about remembering that, you can just click on the thing in the variable editor and it'll show you the syntax. And so you notice there are two, there's a parentheses here, and that's typically how you would index in MATLAB, right? And in this case, it gives you back a table in MATLAB. So it's going to, basically in MATLAB, anytime you use parentheses, it returns the same data type that you were initially indexing from. So, excuse me, I'm plugging in my phone to charge while this is happening so it doesn't suddenly shut off. So I can talk and charge at the same time, no problem. So if you notice, the data type was retained. So the parentheses gave us a table back in MATLAB. And the dot notation gives us back the actual data type that's within the table. So that's great if we only want to access one at a time, right? So we can, if we wanted to access multiple columns at a time, it might be more challenging. So if we wanted to get the data types underlying, we can do something like this. All right, so if you notice, these are curly brackets, and X is now actually the data type that was underlying. So that's actually date time. So those are just a couple of the things that really tend to throw people for a loop, I guess, whenever they're first getting started, because typically when you're indexing in MATLAB, you have the, just typical indexing with parentheses, no big deal, but that also returns the table. And so if you wanted to do something like take the mean of all the data, unfortunately, that doesn't work with a table because, with a mean, you need numeric data, and table has a bunch of different types of data. So that can be, frustrating sometimes if you really want to do that, but that's why that happens. And so if you want to get the, just the underlying data inside, you could do something like this. Also, another fun trick with tables, not trick, but you can also use the names. So if I didn't want to just do 3 and 4 for the numeric data, I could do something like this. And so, of course, that's more expressive. It doesn't help us much with our results, but we can omit the NaN. But so that's just to show that you can index into multiple columns at once with the curly brackets. And that way you can access the underlying data. You're not trying to take the mean of the table. You're trying to take the mean of the data inside. So, remember, I guess, curly is for contents. You want to actually tell MATLAB that you're trying to operate on what's inside the table, and then parentheses are for creating another subset of a table. All right, so I will let's see, check some questions here. There's one, how can I export data from a UI table in MATLAB App Designer reliably? So that's a good question. I'll try to come back to that if we have some time, since it's a little bit different. But one of the things that you can also, since we were talking about UI tables, you can use a table in a UI table now as of a couple of releases ago in App Designer. The easiest way to bring that back to the workspace is to use what's called assign in, and that way your data will be accessible outside of the App Designer. But yeah, you can use a table, itself inside of a UI table. Good. There's how to create more efficient database using tables or an array. For example, aerodynamic database for the aerospace industry. That's a good question. That's quite a loaded question, since there's lots of different ways that you could think of being a bit more efficient with your data creation. So, excuse me. So in this case, a table is basically sort of collecting the underlying data types in MATLAB. So the table itself has a bit more overhead in terms of just the metadata storing, but the I guess the most efficiency is going to come from how you're storing the data inside of it. So for example, our data that we're looking at here, this is a cell array of strings, which is a different data type, the data type that I don't want. So I actually want a categorical array because it's repeated data. And so a categorical is going to be much, much more efficient in this case because it doesn't have to store every single thing individually. It only stores the couple of labels that we have. So that's probably the best advice is to really think about how the data is being stored inside the table. And then if you have times, the timetable is also really helpful for this too, because you can you can have let me see if I go back to our properties. Yeah, anyways, I was going to say with a timetable, you can access some of the information. Oh, I do have a timetable. There you go. Some of the information that you can get just very quickly so that you don't have to operate on it when we're trying to find the information. So that's a couple of pointers for efficiency. Otherwise, if it's a very, very big, if it's something that can't be loaded into memory at all, we have what's called a tall table or tall arrays, and they keep things out of memory. So you don't need to, basically load everything in. If it's a very, very large, you can just basically create a pointer to it, queue up the operations, and then tell it to do the operations. So we could come back another day and talk about that. There's some good information in documentation, but that's basically if you have so much data that it can't be, loaded into memory easily, unlike the ones that we've been working with. But very good question. I think that's something that people really worry about, especially if you're dealing with a lot of numeric data that, oh, geez, if I use this big crazy data type with all these labels and things, it's going to cause a lot of extra overhead. But it's a few bytes, so it's not too bad. It's really more the underlying data. I'll also say that in terms of efficiency, when you're accessing the data, I'm just going to actually make a new tab for this. All right, hold on. Maybe that's not the best way to do it. So whenever you're doing your indexing, anytime that you can use the dot, that's going to be your most efficient indexing. And again, sometimes that doesn't work as well because you need to do, maybe you need all of the data in your array to be operated on. But anytime if you're trying to loop or do anything like that, this is definitely the most efficient way to access it. And a lot of people will try just, to think of everything like this because of the row column indexing is very natural in MATLAB. But this indexing is going to be more efficient. Just because it doesn't have to figure out what data type it is and do some of that thinking. Sorry, for lack of a better way to put it right now. So that's another good one. this is kind of a pointer I was going to save to the end, but since we're talking about it, I wanted to mention a couple of people have asked me before about looping in tables. So we'll talk later about how to avoid having to loop in tables by using nice functions. But there's a good way to do it efficiently. And basically, since you can use the names, you could do something like this. I'll show you another fun trick. Width. So there's height and width for tables. So that's, the height and the width, just to make it a little easier to access that without using size. So I don't know what I'm going to do with this. Whatever, we'll just go like this. Okay, so that just didn't really do anything except for extract data every time through the loop. But I wanted to show that you can actually use this dot notation indexing in a loop as well. So you don't have to, create your row column index and then go through it that way. This is the most efficient way if you're going column wise. And you can also, if you only have a few variables that you wanted to work with, you could type out those variable names and then just loop through those. So again, it's one thing that is not always very clear whenever you get started at first. All right, I'll pause here. There's another question. What was the magic with omit nan, and what was the problem to begin with? Very good. Thanks for keeping me in check. I just go along without explaining things. So if you look at our data, we have some nans, some nat, N-A-T. So this indicates missing data in MATLAB. If we were to look at the data outside and say an Excel spreadsheet, we would probably find missing blanks in the spreadsheet. So in order to keep it rectangular and to make it make sense for the person doing the analysis, we keep a nan or a nat or undefined, as if it's categorical, as a missing placeholder. And so generally the MATLAB functions will return a nan or a nat that's not a number or not a time whenever you have those or whenever you come across them. And you can do things to find where they are. For example, is missing. So that'll give you an indication of where the missing data are. And there are some nice functions now that will help you deal with those. So for example, I showed mean, wherever that went, and it just has a flag now that says omit nan. So a lot of the summary stats functions like this have that flag now. And otherwise you can use, there's RM missing and fill missing. And also, just for fun, since we're talking about it, if you're using a live script and you're using, I think 2019B, there's also a little app that you can use to identify and clean up your missing data. So that's a long answer to that question. All right. Let's see. There's another question about importing an XLS file using read table, but only 2 columns that are not connected to each other. Oh, good question. Let's check it out. All right. So if you don't know off the top of your head, which I never do, go to the doc. So I'm not sure if it's available here. And I can probably get back to you on this one if I don't see it right away. Generally, you can put in a, where is it here? Here it is, the range. I believe this one does look like it has to be connected. So that was one of the points of the question, say you only wanted this column and another column. Let's check another function. So detect import options goes along really well with read table. And this is really also important whenever you're working with tables in MATLAB, which is why I'm definitely going to spend time on it, because you want to make sure you're bringing it in the right way to begin with, right? So this has a lot of options, and I just wanted to see if there was an option here for the range. Okay, so this one I think will allow you to pass in a vector with 2 different ranges. So that's the way to go there. So you would do import options first, and then pass that into read table. All right, so another good one, can we remove the repeated things in data? Good question. So that's a great one because I wanted to show some of the nice functions that you have with tables, and this gives me a great opportunity to do that. So there's different ways to think of repeated data. Say, in this case, it's naturally being repeated because, it's southeast, southeast, those are just two of the same locations. But maybe you have accidentally, multiple rows that are exactly the same information and you aren't sure how to figure that out. You could actually use unique on the whole table to see that. So if we do unique of data, looks like it's exactly the same size. So it seems like, everything is pretty, well, unique in this data set. But you could also look at each individual column. So say you wanted to make sure that outage times, or you wanted to find where outage times were not unique. Okay, those all seem to be unique as well. But let's find something else. I guess we can use the region because we know those are not. All right, so there's only 5 unique elements in the region. So we kind of knew that already, but this is just for the sake of example. We can also get the indices back. So let's say now we want to get those the information back out of the table that were unique. We could do this. So let me expand this more. So basically all I did here was find the unique regions in that variable, and then get the indices or the locations of where those were. And then I used it to get the data back out of the table. And then this is just saying, give me all of that data. So that's a really good question, and that's something that happens commonly, especially when you're working with timestamps. I think that's something that, the times are also nanosecond precision. They're stored, in great precision in the background. So if you do unique on the times, that will be really helpful as well. I also wanted to just point out a couple of other options here. So these are all available in the documentation. It's just a little easier to have it all in one spot. And it just gives many of the functions available on tables and timetables. So some of the things that you used to have to do sort of by indexing, like, where was this? Add vars, if you want to add a variable to a table, or remove vars, rename vars. A lot of these things are really easy now. So you don't have to go, I don't know, figure it out yourself. But the rearranging is a good question. So I saw somebody asked about that. Move vars. So let's say, let's try that with data. All right. Let's put region. We'll move it after cause. So there's nothing really magical going on. I'm just forgetting exactly the syntax. And when I get to the next spot, I just hit tab and it gives me the options. So it just moved region, which was over here, after cause. So there was an option for before, after. So that's an easy way to rearrange things. Another one that happens a lot in sort of financial data is when you have sort of a table within a table, there's a couple of options for that too. So that's inner to outer. It's sort of making an inner table, sort of promoting it to the outer table. And merge vars does the sort of opposite of that. So I definitely recommend checking those out. Add vars is another. Also, if you want to just quickly do something, like let's say we want to just add the time difference, the duration of the storm. Let's say the restoration time minus the outage time. So I just created a brand new variable called time diff, and it's just outage or the restoration minus the outage. And so that's how you can, add them on your own, or we could have done add vars time diff and then filled it in with a vector if we had already created it before. But it gives you an idea of how, to kind of quickly work with tables, and also definitely use the tab complete. That's really helpful. Another one that people, I'm just going to make up a silly matrix real quick, because this is something I think it's not really a trick because it's in the doc, but it's okay. I'll explain in a sec. All right. So I mentioned about the case where you have all numeric data and you want to treat it like a matrix, right? You wanted to do, if we wanted to do the mean of all these things, well, it's not going to work. Oh, that's just annoying, right? But you still need a table. Maybe not here, since we're just doing var1 and var2. But if we want to quickly access all of the data in the table, we can do dot variables. And so that actually just accesses every single variable, just like we did with our, dot outage time, dot whatever. This is not going to work. So this is not going to work for our other one, because it still has to know what data type to put it in, and the only data type is a table. So that's really just useful for when you have all of the same data types that you want to access. But I do want to point that out, since it does happen, especially someone was mentioning aerospace, when you have a lot of measurement data like that, it's often numeric, and you can work with it very easily like this. And the name comes from the properties. So just to quickly mention that again, you can change that. So this is the dimension name. So your variable dimension, you can change that if it makes sense to you. So there was one more question that I can get to now on the operating on each data type, or operating on the table as a whole. So I showed how to loop through the table, and each, well, it's actually right here. So we can access each each column at a time. And we showed the different ways of indexing, but you also may want to just do something to the whole table, and you can't use that dot variables notation. There's what we call array fun, row fun and var fun. So let's go to the documentation actually for this, because there's a lot of options. So var fun is basically you want to apply a function to each variable, var fun, and row fun is applying it to the row. So I think of var fun as sort of it's really useful for aggregations. So something like the mean, that's a really easy one to show with var fun, although it still might not work if you don't have the right variables. But with this, you can actually specify what variables to work on. There's some grouping functionality, different ways to handle errors and things like that. So if you are doing something a bit more sophisticated that you can't use that syntax, it's worthwhile to show this. At the opposite, or not opposite, but row fun basically operates on each row in the table. So let's just quickly show, I guess this is not a great one, but no, we can use our data again. All right, so let's do a better variable name. I'm terrible at that. But the trickiest thing about var fun is that you have to pass in a function. So passing in a function in MATLAB, you pass in a function handle or an anonymous function. So I'm just going to quickly show it without talking about it, and then I'll talk about it. Show the error again. So just to convince you, I'm still trying to take the mean through this fancy var fun thing that Heather's showing me, but it's still not working because it's trying to operate on every variable. So I can tell it, don't do that, just operate on a few. So input variables, and we'll just say our loss and customers. So of course I have to, ooh, this is great. I'm going to explain this too, I swear. Okay. so many things that I just did. All right, so the first one, I was able to take the mean like we saw before, and I got the nans like we saw before. So I passed in the function as the function handle, so it knows what function to apply, the data, and then let it know what to operate on. So what I'm doing here is I'm passing this to tell it to take inputs, and then inputting omit nan. So just because that's a little bit confusing, I think it's worth a mention, especially if you're just getting started with MATLAB. The function handle is a way to pass a function into a function. So for example, fplot, we need to pass in the mean, right? And if we passed in just the mean itself, we would error because also it would error for other reasons. But it's trying to evaluate mean. It's not actually understanding that I'm passing mean into the function. So that's what I do. Okay, well now I'm just using fplot wrong. But that's the idea is, instead of just saying, a function name is trying to evaluate, you pass the function handle. So if I wanted to pass more than, more inputs to mean like that, I do something like this. So now if I had, like h is basically the mean function. So that's basically what I'm doing. I know it's a little bit confusing. I could probably spend an entire live stream talking about this. But this is handy for these kinds of functions, which are sort of generic, and it's up to you to pass in what you want. And a lot of times it can be easy to just pass in a function that you have written if it's something complicated. But again, just to kind of clarify what I was doing there. And so I'll go back. What was I talking about in the beginning? That was far fun. So, again, this is a silly example since I showed 20 different ways to do it. But this is useful for, applying your own kinds of functions along the table. Can you apply a function without explicitly defining the columns? So I guess that would be, I'm passing it in here just because my function wouldn't work on that. But say, if I just did, let's do something boring like length. We don't need to specify the columns that we're working on since I want all of the data there. So this is more for, if you don't want the function to operate on it. All right, another one was, can you put the data in a 3D matrix if you want to do that? Good question. So the easiest way to do that would be table to array, the opposite. But you would have to add another, you would have to do cat3 to add the extra dimension. And so this also happens a lot in, kind of like financial type data or, where you have a date over time and you have, locations and you have information. That would make sense. It's just the array to table or table to array is for a 2D array. So you would have just one more step to do concatenation. Good question. That also is interesting because I didn't mention that each of your columns in your or each element of your table could also be any dimension. So the 3D matrix made me think about images. And this happens frequently when you're working with images. Let's say, we had a picture of, I don't know, the house or the tree that was impacted by this storm. Each element of a column could have a 3D array in it. So just, wanted to, well, I guess I don't have to, I can show you, I don't have to prove it. Okay, I wasn't sure if that was gonna work. Let's do add vars. All right, you can do it this way. I'm losing my mind. Okay, I'm really losing my mind. That's okay. Oh, that's why I had caps lock. the fun time of the stream where you just watch Heather think and try things and lose it. So, all right, there we go. So just to prove it, I have an image in this block of the array, and the rest are filled in with empty cells. So you could put different kinds of things in these, just again, to kind of convince you that these are quite flexible and versatile. And again, in this case, you might want to use a var fun or array fun if you wanted to, work across all the, work along all the images. You also could just use a loop. So I talked about var fun and row fun. It's really just to avoid looping down the rows. That's just going to be more efficient. It's MATLAB. There's a function for that, but it's not going to be terribly slow if you just loop too. That's not a big deal. But again, when you're looping on the columns, it's much more efficient to use the dot notation. So I'm just going to go back to the documentation page just to kind of close it out here. The best place to see, there's a couple of videos, there's a bunch of examples on tables, timetables. So for a lot of the things that you need to do, there's probably an example. Also, I showed some of the hard things because they're things that people have a lot of questions about, so I wanted to answer them. But there are a lot of really nice functions that operate very easily on tables. So a lot of the things that you'll see over the last couple of releases, for example, like group summary and RM missing, fill missing, those all just work directly on the table itself. So there are a lot of really nice functionality, lots of nice functionality for that now, that you don't have to go in and do all the indexing yourself. I just spent a lot of time talking about that since it's hard. Let's see. Oh, that actually reminds me of the reason I wanted to show varfun is that it's a really easy way to get the classes of the images. So I showed summary. If you want to just quickly get the class type or the data type of the function, or I'm sorry, of the tables, but we can use varfun and just use class. And so that gives it directly. And then we can go in and index if we wanted to just do that, do something with that. The other thing we could do is there's what's called var type. So if we wanted, I know I showed this like literally 100 times, but if we wanted to just get the numeric data, just call it this. So we can use this var type, and we can just say numeric. And so it's called an indexing object, and it just basically, it just makes it convenient so that you don't have to pass in like a logical index for the class names. You don't have to do as many steps for that. So that's one really easy way to just operate on the certain columns that you want. All right, so I think that pretty much wraps it up. I'll just pause here for a moment with any questions. I'll skip joining just because that is crazy amount of time that we could get into talking about that. But your typical outer join, inner join, and join functionalities are there. And if you're using timetables, we spent a whole 40 minutes talking about synchronizing in another live stream. So we can talk about that. But there's some great examples. And also don't forget, if you're using the later releases of MATLAB in the live scripts, you have the ability to join and synchronize and do all of these things with just a couple of clicks. So definitely take advantage of that too, especially for the things that are very iterative in the data analysis. So I'll wrap it up here, and thank you very much for your attention, and I hope you enjoyed, and I hope you can use tables and timetables now. And please keep coming with any questions in the comments. We'll try to answer those after the fact. So thank you very much. I really appreciate it. And thanks again. Hope you have a good one.